Good morning, everybody. This video is going to be us looking at the biological explanations for schizophrenia. So by this point, if you're watching this video, hopefully we've moved on from the really tricky part of schizophrenia, being the first bullet point. And we're moving on to what causes schizophrenia. Now, schizophrenia is really easily structured. You've got first week, really difficult bullet point. Then the next 2 weeks, you've got biological explanations, psychological explanations. Then you've got biological treatments, psychological treatments, then finishing off with interactionism. So this is the first of four focuses on biological and psychological explanations and treatments. And there's a lot to this, right? So you are looking at three key theories, one of which kind of has three theories within it. So let's make a start. I'm not going to ask you these questions, but we are going to move on to the first one. In fact, actually, you know what I'm going to do? I'm going to show you the specification. Because I'm going to show you the three theories that you need. Now, as you've just seen, the first one was genetics. So you know straight away that you're going to have to know some genes that are responsible for the onset of schizophrenia. So I'm going to try this again, but I always ruin this. Oh, he's nailed it, and he's absolutely nailed it. So the theory that we are looking at is essentially this one just here. We're going to be looking at genetics. We're going to be looking at dopamine hypothesis, and we're going to be looking at the neural correlates. Now, there is a bit of confusion of how to structure this. My way of doing this is just one way, right? So if you're watching this and you're a little bit confused, then go with either what your teacher said or what I've said. But basically, there's a bit of variation in how this is taught. The way I teach is just one way. So let's make a start. Genetics, right? Clearly, genes do play some role. We see schizophrenia through a family tree repeatedly. Same thing with depression, same thing with alcoholism, for example, same thing with some cancers. But that doesn't necessarily mean that it is entirely genetic. Don't forget, the closer you are related to somebody, not only do you share their genetics, but you also share the same environment. So you can't entirely rule this out. But as I say, there's a strong correlation between a family member having schizophrenia and then a close relative also developing that as well. Now, if you have schizophrenia in your family, like an aunt, for example, I don't want you to panic, even if it's an MZ twin, an identical twin who has schizophrenia. There is no 100% rate where you would get schizophrenia just because the person who's related next to you got it. But it is generally believed that the closer you are to the diagnosed individual, the more chance you have of showing this. I'm going to show you a graph of Gottesman that shows this. However, as the screen says, it is absolutely impossible to separate out both the genetic side of things from the environment, because no matter how hard we try, it's just impossible, basically, right? So even if you were to get two twins, and rear them apart, grow them apart from each other, for example, and they don't know each other, that's one way of doing it, but you still can't fully separate out the biological from the environmental. So one area that you may need to know about here is the way in which genetic research is done within schizophrenia. So you probably do need to know a bit about twin studies, a bit about adoption studies, not really that much about family studies out there, to be honest. But you do need to know a study from at least twin studies and adoption studies. So let's go with that, right? So let's have a start with twin research. And the main one you want to know here is Gottesman, 1991. So Gottesman did this graph just here. You've got third-degree relatives who you share 12.5% of your genes with. You've got your second-degree relatives, which you share 25%. So first-degree relatives, 50%, and 100% of, almost 100%, is shared by identical twins. Now, as you can see, the closer you are related to the individual with schizophrenia, the more likely you are going to. So the general population is about 1%. You do see varying things there, but the general population is about 1%. If your first cousin has schizophrenia, essentially you have a 2% chance of developing it. So that doubles the original rate. If one of your children has schizophrenia, actually, if one of your grandchildren have schizophrenia, one of your grandchildren, where's grandparents? If one of your grandchildren have schizophrenia, you have a 5% chance of developing it. Now, if your DZ sibling, so your non-identical sibling, if you were part of twins, for example, if they were to get schizophrenia, Gottesman calculated that it was a 17% chance. By the way, I know it says 1966 up there. That was Gottesman and Shields, but this, I should change this actually, because this came from the 1991 study. However, if your MZ twin, your identical twin, gets schizophrenia, you share 100% of your genes. So if schizophrenia was entirely genetic with no influences, if your gene, if your identical twin got it, whom you share the exact same genes with, you would have 100% chance of getting it, but you don't. You have a 48% chance. So straight off the bat, one thing you need to know about the genetic theory of schizophrenia is it does not fully explain schizophrenia. If it did and your MZ twin got schizophrenia, you would be certain, in possibility terms, you would be certain to get schizophrenia. Now, that's still quite bad. If your identical twin gets schizophrenia, you are 48-fold more likely going to get schizophrenia than the average person from the general population. It's impossible to deny the power of it. Now, you may turn around and correctly say, well, hold on a second, K-Dog. Identical twins are raised in almost the exact same environment, same friends, which always confuses me, same friends, same clothes, same school, same teachers. So maybe it's their environment that's causing this schizophrenia, and the reason why they're both having schizophrenia is because they both had the same environment. And I can't really argue against that if you were to say that. So that's a big criticism. But as I said, Gottesman found a 48% concordance rate among MZ twins, but it goes down to 17% with DZ twins. DZ twins don't share as much environment as MZ twins. Monozygotic and dizygotic, if you didn't know that. Monozygotic is one zygote that you're identical. Dizygotic is two zygotes, you're non-identical. But yes, you essentially have this situation where your MZ twins are much more likely going to get it than your DZ twins. And that is this important point here. Gottesman also found DZ twins have a 17% chance. The difference between MZ and DZ would largely go down to genetics. So a bit of evaluation just here. The high concordance rates in identical twins compared to non-identical twins could be because MZ twins are treated very similarly. So we've discussed that already. And no piece of research has ever found a 100% concordance rate. I'm not entirely sure, but 48% has got to be one of the highest ones that's ever been found. That's not even a majority. It's close to a majority, but it's not even a majority. So the fact that no research, this is important, the fact that no research has ever found a 100% concordance rate means that there must be other influences, and thus schizophrenia is only partially caused by genetics. It's not the whole explanation. And that actually results, by the way, in lowered explanatory power. And that's a really important term to write down. It results in lowered explanatory power because the genetic explanation therefore can't fully explain all of schizophrenia. The other problem as well is you don't really see twins that often. Twins are relatively rare in many ways. So the samples do tend to be smaller. And that's quite important because not only do you have to find twins, which are already difficult, you have to find twins that are willing to engage in research, and you have to find twins who are willing to engage in research that one of them or both of them have schizophrenia. So the samples you get are very, very small. Now, adoption studies have only got Tienari. I think they looked at Danish people. I don't know why. I hate Annie. I hate her so much. I don't know why. I don't know why. I've tried blocking her off from this screen. I'm just going to hold my hand up because I get really angry when I see her. I have no idea why. Something in me. Anyway. So, this is a bit of a confusing study, so let me try walk you through it at a slower pace. Tienari, right, 1991, same year as Gottesman, looked at adoption studies, looked at adoptive children. If and the main thing I would need you to take away from this, because this is quite important. This is an important study. None of his adopted children knew or had any contact with their actual mother or their actual biological family. So they were entirely separate. They were entirely separate. If it turns out the biological mum, had schizophrenia, that kid had a 10% chance of developing schizophrenia. If the mum didn't have schizophrenia or there was no family history, the kid had the normal rate of developing schizophrenia. So this is an attempt. Oh God, I'm going to put this up so I can't see it. This is an attempt to try separate out the biology from the environment, and you need to be able to understand what this actually means. If the mum, who you don't know, by the way, who you've never met in your life, so clearly not an environmental pressure here, if the mum that you never knew had schizophrenia, you have a 10 times higher likelihood of developing schizophrenia, which is quite something, I think. Now, she's gone. Now, I'm just going to get you to pause this and maybe note down some of the methodological issues with twin and adoption studies. You may get asked this specifically. It never has been asked so far. I don't think you will, personally, but family studies is also here as well. I don't have a piece of research for family studies, but you do need to get the concept. You do need to understand the idea of how family studies actually work. Now, further research, and this is a bit more specific, I think. Benzel et al. Identified 3 genes. The COMT gene, or rather, these are when the genes go faulty, by the way. So the COMT genes, the DRD4, and the AKT1. I am in total agreement with you that these are common sense names for genes and not ridiculous names at all for genes that sound like planets. But all of these, and you'll need this in a second, all of these genes are associated with excess dopamine in the specific D2 receptors, which leads to particularly positive symptoms. Now, you do need to know this because the next thing we're going to look at in a second is the dopamine hypothesis. So you need to understand how the genetic explanation says that it causes this. The genetic explanation says that it's the genes that cause the dopamine to go awry, basically, to go wrong. And that's what the genetic explanation is trying to say. So what you need to know about all of these 3, and this is a key term you absolutely have to use, all 3 of these are what we call candidate genes. They are genes that have specifically been implicated in the onset of a disorder. I may have to pause this in a minute because I forgot like the child I am, I forgot my sandwich today, and my girlfriend is driving into work to give me my sandwich because I'm a big fat man-child. So I just need to keep an eye on my phone. So if I pause it, I'm running off to get my admittedly amazing sandwich. It is incredible. Anyway, so in terms of evaluating the genetic explanation, first thing is biologically reductionist. But again, you need to know how to elaborate on that. Well, why is that bad? Well, what's the evidence? Well, it reduces a complex behavior of schizophrenia down to a single variable cause. You're literally saying that this really complex disorder is being caused by one single teeny tiny thing, right? Now, that's ignoring other factors, but it's also reducing it down too much. Now, reductionism is not a dirty word. Reductionism is actually a good thing as well. But in this case, I'm using it as a bad thing. Not only is it biologically reductionist, it's also biologically deterministic, which could be considered offensive because it's essentially saying that we have no control over schizophrenia. And I like this quote just here. It basically says that illness is destiny. What that means is People who have the gene are destined to get ill. I don't like the quote as in, brilliant, well done, but I think it's a good way of summing up. It's saying that illness is destiny, and that's quite offensive, quite socially sensitive, because people don't want to be told that there was nothing they could do, particularly if they're trying to recover as well. But the good thing about this is that if we can figure out who has these faulty genes, we can identify who are vulnerable and then protect them from triggering off those vulnerabilities. So a good thing about this is it does lead to practical applications. Maybe we need to, I don't know, this is a fancy name, admittedly, gene screen. Maybe we need to screen everybody for faulty COMT genes, faulty DRD4 genes, faulty AKT4 genes, whatever it was. Maybe we need to screen people for this, identify, holy shit, you're quite vulnerable to schizophrenia. Well, let's see if we can help you then, shall we? God, okay. Okay, so... but as I said, no 100% concordance rates. Model pill here, and this model pill is about this fact that there is no 100% concordance rates. So again, particularly have a look here. Well, don't have a look at this because I haven't even finished the bloody point. That's very, very embarrassing. So it's only partially valid and credible. There we go. We'll just pretend that didn't happen. Try and edit that out of the video. Okay, so model pill, again, focus on the elaborations, right? I think students are quite good at the evidence. I think students are quite good at your stage at the evidence, but the elaboration, generally, people, they don't know how to elaborate. They don't know how to say why your point is important. Dopamine hypothesis. This is the big one. So I'm not going to lie to you. This technically should be called the dopamine hypotheses because it has constantly adapted this theory, and I'm going to teach you all of them. Now, I'm not going to go into too much detail here. I'm not going to go through the neurotransmitters reminders. That's another video. But what you need to know is the basic. The initial dopamine hypothesis said that schizophrenia was caused by too much dopamine in the brain. The levels were too high. Basically, someone who was schizophrenic naturally produced more dopamine, and that led to them being schizophrenic. Now, we went away, and I say we, I did very little towards it, but we went away and we did some research, and we found that actually, no, not everyone with high dopamine does have schizophrenia. So and this is a key term, what the theory showed was a scientific adaptability to adapt to emerging evidence. And it was refined. And it turned out not to be, too much dopamine. It was you had a abnormally high number of D2 receptors, dopamine receptors, basically. It wasn't so much you had loads of this, it was you had loads of these here, loads of D2 receptors. Now, high dopamine typically leads to positive symptoms, hallucinations, delusions, for example. If I give you loads of dopamine, so for example, if you were to take some recreational drugs which basically flood the brain with dopamine, you do actually see people have delusions, you see people have hallucinations. They essentially have temporary schizophrenia. By the way, if you have a biological vulnerability like a gene or something, if you then take that environmental trigger of MDMA, for example, or LSD, you can it is known you can trigger off a full-scale schizophrenic episode. So you have to be really careful. It's like that. It's like the vulnerability of that cannabis has on psychosis. If you smoke, or if some people smoke cannabis, it can actually trigger off a psychotic episode because they were vulnerable and didn't obviously know it. But anyway, that's another story for a different day. And this is what I'm saying. Evidence for this comes from the fact that amphetamines, mainly LSD, increase the amount of dopamine and can lead to behavior that looks very, very much like schizophrenia. And small doses given to people already suffering from schizophrenia do tend to worsen. Can you imagine that piece of research, by the way? You already have schizophrenia, then someone gives you LSD. That's going to make things so much worse. And it did. So that is the evidence for the dopamine hypothesis. As I said, it's then changed. And this is backed up by Owens, by the way. Owens found that there are generally a large number of dopamine receptors in dead people who had schizophrenia. And again, that would be useful to know. So definitely write down. However, the dopamine hypothesis up to this point only explains people who have positive symptoms. Because if you have too much dopamine, that leads to positive symptoms. It doesn't explain avolition. It doesn't explain all the negative symptoms, for example. It doesn't explain that. So the theory went away again and did some research and found that actually, hold on a second, it is positive symptoms are caused by an overactivity, so too much dopamine, in the mesolimbic pathway, whereas negative symptoms and cognitive symptoms appear to be an underactivity in the mesocortical pathway. So this theory, the dopamine hypothesis, the full dopamine hypothesis, has excellent explanatory power. Not only does it explain the positive symptoms of schizophrenia, but within the theory itself, it also has mechanisms to explain the negative symptoms of schizophrenia. So it's a phenomenally strong theory in terms of its explanatory power. Genetics don't explain why you have positive or negative. Neural correlates, which I'm going to go through in a second, doesn't explain positive and negative. This theory does explain positive and negative. So, for example, the VTA, by the way, is what's called the ventral tegmental area. It's basically where all your dopamine comes from initially. So there isn't for the mesocortical pathway, as you can see, someone with schizophrenia has got much lower activity than someone who doesn't have schizophrenia. So for negative symptoms, there is an underactivity of dopamine in this pathway. Okay, part of the problem is generally speaking, you have either positive symptoms or negative symptoms of schizophrenia. But there are some people who have both. How the hell do you treat that? Because if you give them dopamine, as in if you give them drugs which encourage dopamine, which I'll go through in a second, then you're going to screw them up here because these levels were already high. If you give them drugs to stop the production of dopamine, well, that's going to screw this bit up. So it's a really, really tricky thing to be able to teach if you have both positive and negative symptoms. Now, first things first, practical applications, very good here, very good. If we know there's a problem with dopamine, we can give them either dopamine antagonists or dopamine agonists, depending on the problem. Now, I am going to go through this now, but what might be a good idea is if you turn to the drug therapy part of your workbook, and it may not have like a part on it, but if you can talk about how dopamine antagonists work, that would be very useful. So you may want to pause the video and move your workbook to the drug therapy part of schizophrenia. You have to go past the psychological explanations. And I want you to make a note of what you have on the screen here, because this is important to how dopamine antagonists work. So going back to the explanations, if the problem is the dopamine, then what we can do, antagonists can inhibit or impair the action of a particular neurotransmitter. So antagonists will slow down or break down or stop potentially a certain neurotransmitter. And they do this by basically sitting in the dopamine receptor sites. The drug will come in and it will sit in the receptor site and just sit there, and it will block off any dopamine that's trying to get in. And therefore, dopamine isn't going to where it needs to be. Receptors aren't being triggered that much. therefore the symptoms come down. And it also increases dopamine reuptake. So for 2 weeks' time, chlorpromazine you will need to know about. You'll need to know about the half-life of chlorpromazine. You need to know about the side effects of chlorpromazine. But I am not too bothered about that just now. In terms of evaluations, there are some obvious ones here, but let's go through them quite quickly. I'm a bit wary of time because my sandwich should be here any minute. It's only a correlation. What causes schizophrenia? What causes what? Does schizophrenia cause the dopamine to go up, or does the dopamine going up cause schizophrenia? So there's no cause and effect here. It's only at this moment a correlation. Fard et al. Did actually find no difference between people's dopamine levels, which does actually harm the credibility because it's suggesting that maybe dopamine isn't the be all and end all. Maybe there are other ways to get schizophrenia other than dopaminergically. You're welcome. But it is also biologically deterministic again, and we've already gone through why that is a bad thing. There is a model answer just here. In this case, I like this point because this is a point that doesn't come up that often. So definitely make a note of this. This is about this theory being scientifically adaptable. It changes in the face of new and emerging evidence, and it doesn't say stubborn and they're like, no, my theory's right. So can we make a note of this point? It's quite a strong point, if I do say so myself, and I do say so myself, so thank you. The last one is quite easy, and this is actually where most teachers will diverge in how they are teaching this because there is some confusion about neural correlates, I think anyway. But I'm just going to keep it simple. We've looked at a genetic explanation. We've looked at a biochemical explanation with dopamine. Now we're looking at, is there anything physically wrong with the physical structure and anatomy of the brain? And in this case, we're going to be looking at ventricles. So this is quite easy, very easy point. There is a correlation between people getting schizophrenia and them having enlarged ventricles in the brain. Ventricles are basically empty sacs in the brain that hold the brain in place. And in people with schizophrenia, they tend to be about 15% bigger. It's not known why this happens. It is only a correlation, so it doesn't have great explanatory power, but there does seem to be a bit of an issue in people with schizophrenia having enlarged ventricles in the brain. The scans you see here, as you can see, these are significantly larger. These black dots just here, compared to a healthy one. So you can clearly see that those enlarged ventricles there. That is what is causing schizophrenia. We don't know why. We don't know if schizophrenia is causing the enlarged ventricles, maybe the same way dementia causes plaque on the brain, or does plaque cause dementia? Don't really know. But it is a bit of an issue. Now, drawing this to an end, I've got 7 minutes to get downstairs and get my sandwich. This is a typical question that you're going to come up. Essay question, biological explanations. What I would want you to be able to write about is, for this, I would say AO1 equals 6 marks. For 6 marks, you need to talk about 8 things to do with biological explanations. 8 separate things. I would say for 8 separate things, you're talking about maybe 2 of the theories we've covered. Talk about genetics, candidate genes. Maybe name the genes, for example. Suggest how it's a correlation between members of the family, for example. And then maybe talk about what one of the genes does and how that links to the dopamine hypothesis. You could then talk about, the dopamine hypothesis, for example, and talk about different stages. So AO1 equals 6, you're needing to write 8 separate things for AO1. In terms of in terms of other points you could have gone for just generally, really, biological explanations, always do this. Always do this. Compare, right? So what could you compare the genetic explanation on with psychological ones? Genetics more scientific, because it's more observable. I can't see family-based, I can't observe family dysfunction like I can observe whether you have a gene or not. What could I do? I compare them. Similarity. They both have practical applications. So can we please just start doing this more often? The beauty about comparisons points, by the way, you do not have to. You absolutely do not have to revise for them. You can think of them off the top of your head in the exam. It's reductionist, it has major implications, and it does actually contribute to the diathesis stress model, which is what we're going to cover quite soon. But essentially, that is everything for the biological explanations. The next video we're going to be looking at is looking at psychological explanations. I think it's harder than what we've gone through today, personally, particularly the cognitive explanation side of things. But I hope that was useful. Expect an essay on this at some point. Big part of the spec. Peace out.